Okay, now this was the easy part. This was in Cartesian coordinates, XYZ. That was easy. But that actually can exist in all kinds of situations. So what will these values be if we are when we have spherical coordinates? So spherical coordinates are r, theta, and phi. How do our values change? So my divergence, let's start with gradient. My gradient will be del t partial over partial r of t r hat plus 1 over r partial over partial theta of t theta hat plus 1 over r sine of theta partial t over partial phi phi hat. And do we all remember, or did we look at the videos? So to remember where r, theta, phi's exist, this is my r vector. So this is my r, that's my theta, and the projection of it gives me my phi. Just reminding ourselves, right? Phi is the sweep angle. Theta is how much it comes down. Oh, Nick, those are, we spent the entire chapter 1 of Newtonian talking about this. So they're all in the videos. You can watch them in detail. Okay, next, what was next? Divergence. What was divergence? The dot product, and I called it E. And that will be 1 over r squared partial, oh, make sure the dot is partial over partial r squared VR plus 1 over r sine theta partial over partial theta sine theta E theta plus 1 over r sine theta partial over partial phi of E phi. Note, I don't have r hat, theta hat, or phi hat. Why? Because it is a dot product. Dot products, those go away. Because your answer should come out to be a number, just a scalar. That's why you don't have ijk's. Then the next one was called a curl. And the curl will be 1 over r squared sine theta r hat I theta hat sine theta phi hat. Now in this case, the answer should be a vector. ER r v theta r sine theta E phi. One other thing that Griffiths introduces us to is called a Laplacian. And that's when you do squared over the function t. And t is a scalar. And he calls it this, partial over partial r squared sine theta partial t over partial theta plus 1 over r sine theta squared partial squared t over partial phi squared. Now, do I expect you to memorize that? Probably not, but you should have it written on your note cards. Cylindrical coordinates. How do these things change when we go into cylindrical coordinates? So in cylindrical coordinates, we have r, phi, z. Remember cylinders? So this was our sweep angle, phi. This was z going up and down, and r was the radius. So the gradient for this case will be del t, partial t over partial r, r hat plus partial over partial phi of phi hat. Oh, I think this has a 1 over r. Plus partial t over partial z, z hat. It does, right? Yeah. Yeah. And remember, this is the t is a scalar. And so this will just give us the slope. Gradient is always a slope, just to how far you go down or up. Next one is going to be the, what was it? Divergence. Divergence. And divergence is the dot product. So the answer for divergence will just be a scalar, just the number 5. And it will be a dot product. So it'll be partial over partial r, 1 over r, r, er, plus 1 over r, partial e phi over partial phi, plus partial e z over partial z. Okay, next is going to be curl. And curl is the cross product, right? And so we will have del cross E. So this will be r hat, theta hat, z hat, no, phi hat. I'm calling them phi's. And so this will be 1 over r and 1 over r, partial over partial r, partial over partial phi, and partial over partial z, and er, e phi, ez. And then the Laplacian is just squared of that partial over partial r, r over a scalar plus partial squared t over partial phi squared plus partial squared t over partial z squared.